So today, let's talk about a really cool idea. How do you build AI teams that are smarter and way more effective? We're not just talking about one super smart AI, but whole groups of them working together. And that, of course, brings up a fundamental question. How do you even organize a team like that to solve the really big problems? I mean, think about it. You've got this huge, messy problem you want to solve. A single AI, no matter how powerful, is probably going to struggle. So the obvious answer is you build a team of AIs. But how do you get them to work together? Who's in charge? Do you have a boss? Who's telling everyone what to do? Well, the way it's usually been done is what you see here on the left. It's a classic top-down hierarchy. You have one central AI, basically the boss, that dishes out tasks to all the other worker AIs. It seems logical, right? But it has this one giant, critical flaw. What happens if that boss AI fails? If it gets overwhelmed or just makes a bad decision? The entire system just grinds to a halt. And this gets us right to the heart of what researchers are calling the AI boss problem. This centralized model, while it looks simple on paper, is actually filled with hidden traps that stop these AI teams from ever really reaching their full potential. Let's break down exactly what's wrong here. First, like we said, it's a single point of failure. Everything depends on that one boss agent. Second, it just doesn't scale well. As you add more agents and the problems get bigger, the boss becomes a bottleneck and the whole system slows to a crawl. Then there's adaptability, or the lack of it. The agents are kind of stuck in their roles. They can't easily pick up new skills or pivot to a new kind of challenge. And finally, and this is a big one, you've got major privacy issues. If you want agents from different companies to work together, all of their sensitive information has to go through that one central hub. That's a huge risk. So what you end up with is a model that's just too rigid, too fragile for the kind of complex, ever-changing problems we want AI to solve. It just makes you think, come on, there has to be a better way to do this, right? And you bet there is. This is where a brand new framework called AgentNet steps in. The name itself gives you a pretty big clue. It's a network of agents that works as a team, but a team with no boss. And this visual just shows the difference perfectly. On the left, you've got that old, stiff hierarchy. But then you look to the right and you see AgentNet. It's this dynamic, living system where agents talk directly to each other. They figure out how to route tasks, and if one agent goes down, they just reroute the task on their own. The team literally organizes itself. The key word here is decentralized. It might sound technical, but all it really means is there's no single boss, no central point of control. The decision-making power is spread out across every single agent in the network. And that's what makes the whole system so incredibly resilient. If one agent fails, it's no big deal. The others just work around it. So how in the world does AgentNet actually pull this off? Well, it's all built on 3 core ideas or pillars that let it work so differently from the old way. Let's take a look under the hood at each one. Pillar number 1 is that fully decentralized idea we were just talking about. By simply getting rid of the central boss, you completely erase that single point of failure. The agents are free to coordinate among themselves and even decide to specialize on their own. This leads to something the researchers call emergent collective intelligence. Basically, the team starts to think for itself, figuring out the best ways to solve a problem without anyone telling them. Okay, pillar number 2 has a fancy name, dynamically evolving topology. But don't worry, it's a really simple idea. Topology is just the structure of the network, who's talking to who. In AgentNet, that structure isn't set in stone. The network literally rewires itself as it works. Connections between agents that work well together get stronger, and connections that aren't useful just fade away. And the third pillar is adaptive learning. Each agent has its own memory of what's worked in the past. So when a new task comes in, it can look back at its own successes, kind of like consulting its own personal experience, to make a smarter decision. This is how each agent learns, gets better, and eventually grows into a real expert in its own right. So we've covered the what, but let's dive into the how. How does a group of generalist AIs actually transform into this super efficient team of specialists? The process itself is just fascinating to watch. So it all starts at stage 1. Imagine it's day 1. The network is what they call fully connected. Every single agent is connected to every other agent, and they all have the exact same general set of skills. Nobody's an expert yet, it's a completely level playing field. But then we move into stage 2. As the agents start tackling problems, this is where the magic happens. Some agents just turn out to be better at certain kinds of tasks, so they start to specialize. The system sees this, and the connections between agents that collaborate successfully start to get stronger, almost like they're forming their own little departments. And by the time we get to stage 3, the transformation is pretty much complete. The network has totally evolved, all those unproductive connections have been pruned away, leaving behind a super lean and efficient communication system. The agents are now experts who know exactly which teammates to call for help on any given problem. The team has organized itself from the ground up. And this isn't just a cool theory, this is real data. Check this out. These charts show the skill levels for individual agents, and as the team grows from just 3 agents to 9, you can literally see them develop their own unique specialties. This agent over here becomes a pro at reasoning, another becomes an expert in language, and another one gets really good at math. They're teaching themselves how to be an effective, diverse team of experts. Okay, a self-organizing, self-improving AI team is obviously incredibly cool from a technical perspective. But let's zoom out. What does this actually mean for us in the real world? Why is this such a potential game changer for the future of AI? Well, for one thing, it just flat out works better. Look at these numbers. Across all kinds of different complex tasks, from math and logic to using software tools, AgentNet consistently beats the old centralized boss models. And look at that logical QA task. It's not just a little bit better, it's a massive 30-point leap in performance. So what's the big takeaway here? This matters because it means we can start building AI that is so much more robust, systems that won't crash if one part fails. It's truly scalable, so AI teams can grow huge without hitting that central bottleneck. It also protects privacy, which is absolutely crucial if we want different organizations to collaborate securely. And maybe the most exciting part, it allows for emergent intelligence. The AI team can literally discover solutions and strategies that no human ever programmed into it. And that really brings us to the final massive question. We are shifting away from just programming a single AI to instead creating the conditions for AIs to form their own expert teams. So when AI can self-organize, evolve, and learn like this, what kind of impossibly complex problems will they solve for us next?